Hello everyone. In previous video, I have discussed about the basic concepts of transmission modes which are all available in the communication system. Fine. Today we are going to see about the transmission lines and the types of the transmission lines in this video. So, the transmission lines are defined as the path of carrying alternating electrical signal from the source to the destination. So here the transmission lines are classified into 5 types. One is balanced to wire, another one is coaxial cable, and the third one is a waveguide, and the fourth one is microstrip, and the fifth one is fiber optics. Right? First one is balanced two wire line. So here the balanced two wire line is constructed with the help of a insulating spaces, which is used to maintain the distance between the transmission lines and the conducting wire throughout the communication process. Fine. So this is the diagram for the balanced two wire line with insulating spaces. So spaces is given between the transmission lines and the two conducting wires equally throughout that distance. And the next continuation about the balanced wire line with. So here low loss dielectric means here the two conducting wires are kept parallel to each other with the help of a plastic material. So it is used throughout the conducting wires. In another one is with the help of the rubber piping we have used in the circular or rectangular shape. So this is used to it is kept at the opposite side of the piping throughout the construction process, which remains parallel to each other. And there are certain merits and demerits of the transmission lines. So here the merits are, it is cost is low and we can easily design it, simple design, and which consumes a handling of high power. And a few demerits are available in this type. So external interference of the signal in open two wire line is more when compared to the others, and external disturbances will be there. So it is quite a twisty path. It consists a twisty path, and another one is it can't able to operate at a very high frequencies. Fine. We are moving to the next type, and the next type is about a coaxial cable. So here the diagram shows the coaxial cable. So this cable consists of an inner conducting wire which is made up of a copper. Over this conducting wire, the coating of polyethylene or a Teflon material is carried out. Then it is enclosed in the barbed wires in the shape of mesh. The outer surface of the wire is enclosed in a plastic jacket. So this is one kind of the transmission line cable. Here the merits are the external interferences can be minimized and it can able to withstand the high frequencies. Then demerits are it is costly and it is very difficult in designing when compared to the other methods of transmission lines. It handles only low power transmissions. And we are moving to the third type, and third type is about the waveguide. So here the waveguide is a type of a transmission line which carries the microwave frequencies from a source to the load. Here the energy is a form of a magnetic field and the electric field, which is perpendicular to each other. Fine. So here the types of waveguides are circular and rectangular. So here we see about the rectangular waveguide, which is a circular waveguide, which is circular in shape, which is hollow from the center and polished from the interior portion. So here the outer surface of the waveguide is coated with the insulated paint in order to avoid the dust and the dust particles which is depositing on that layer. And these types of waveguides are available in different lengths and size in order to fulfill the requirements of the circuit. So based upon the circuit, the shape and the size will get varied, length and the size will get varied. And next one is about rectangular waveguide. This is designed from conducting material in a rectangular shape, which is hollow from the center and fully polished from the interior. So here the outer surface of the waveguide is coated with the insulating material or a paint in order to avoid the dust and the rust. So these types of waveguides are available in the different length and the size based upon the conception and also based upon the requirements of that circuit applications. Fine. So here also there are uses in the waveguides. So it is mainly used for carrying the micro frequency range signals, and it handles a very high power of energy, and it is used in the airborne radars, and it is commonly used in a communication system, satellite communication and navigation like that and all. So on the next one is about the microstrip line. So here the microstrip line consists of a conducting plate which is made up of a copper material which works as a earth plate in the circuit. So this is a thick coat of insulating material over a copper plate which is made up of a fiber gas or the polystyrene. So this insulated plate works as a dielectric in a microstrip line. So here the merits of using the microstrips are very high frequencies and small in size, low weight, losses are minimum, and the weight is also low, and these are the merits, and demerits are like it is a very cost of microstrip is high when compared to the coaxial and the two-wire line. So it cannot be used for the transmission line between a source and the destination. So here the transmission line cannot be easily used in a twisty paths between the source and the load. And the next one is about the fiber optics. Clear? So fiber optics means it transfers the it is a medium to transfer the signals in the terms of light. So fine, here it is acting along the glass or the plastic stand or a fiber. So it is used for a long distance and high performance data networking. So this circuit is the basic blocks of the optical communication. So initially the input may be in any form. Input is in electrical form, right? So here the communication throughout the travel, the signal will be in a light. We are going to transmit a light, making an a light communication over here. So initially the input is an electrical input. We are giving that input to the driven elements. So here basically the electrical signal is converted into an optical signal. Later it is converted into an optical the optical signal will be carried over a optical fiber, and the optical is converted back to the electrical signal. So here the three things are plays a very important part. One is transmitter, another is the optical fiber, and third one is about the receiver. Fine. So here the optical data link needs to transmit that can be efficiently convert the electrical signal into an optical signal and latch the data containing the light down the fiber optics. So here the fiber optic link also receives the signal efficiently and recovers back to the original signal. So here the diagram shows the input is given to a driven element and it going to the light source. Here it is converting into a light signal. That light signal is transmitting through this optical fiber cable. Here optical slicing means joining. We are joining more than this the optical signals, and we are going to the repeater. The optical receiver will receive the optical signal, it convert into an electrical, again it goes to the optical. So likewise the process will repeat it, and here a receiver part plays the reverse operation of the transmitter. Fine. So this is about the basic construction of the optical fibers. Right? There are a few losses involved in the transmission lines like radiation loss, conductor loss and dielectric losses. So these three losses are occurring in the transmission lines. So first one is about the radiation loss. When a high frequency current or a voltage wave form a flow through a transmission line, the magnetic field expands and it get collapsed around that transmission line at the same rate of the input frequencies. When conductor heating means when a current flow takes place throughout the transmission line, the conducting wire of that line start to be heat up. So due to that heat, there will be a reduction of energy from which is produced from a source to the load. And third one is about dielectric loss on heating. So here as the transmission lines are composed of two parallel conducting wires and current flows take place through a line. So here the potential difference exists between those two lines. So here the potential difference causes the leakage of current through the dielectric. As a result, the heating of dielectric material takes place, which reduces the energy produced by the source or the load. So that's all about the types and the losses occurs in the transmission mode. We will discuss the rest of the topic in the next session or next video. Thank you all.